Morning, everybody. Now, sorry for the inconvenience today. Cannot take class from the studios of our institute because of being not well today. So, only for today, I would be taking the class from home, and I won't allow you to face any problem as far as taking the class from home is concerned. Everything would be dictated, everything would be drawn on the board, nothing would happen to you. Clear? Now, let's start. Now, in the last class, we were responsible for discussing air pollution, and we started discussing what? We started discussing e-waste, electronic waste, and we defined e-waste also that it is a type of waste which has electrical or electronic circuit and also has a power source. So that kind of waste would be called as what? It would be called as e-waste, and it is a concern. Why? There are many things which you have to notice in the concern. One thing is what? That it is a concern in India. Why? Because India is regarded as a dumping station of e-waste by the developed nations. Clear? First thing. And India is regarded as a dumping station of e-waste by developed nation. Why? Because the disposal mechanism of e-waste is a costly affair. It can be energy intensive, it can be costly affair. For example, when we talk about pyrometallurgy is for extraction of gold. It is an energy intensive process. But when we talk about hydrometallurgy is also used for disposal of e-waste, in which aqua regia is used. It is a costly affair. So either it happens to be a costly affair, or it happens to be costly affair, or it happens to be what? It happens to be energy intensive process. So disposal mechanism of e-waste is difficult. First thing. The second thing that you have to know is that as far as disposal of e-waste is concerned, now India is regarded as a dumping station. Why? Because even the developed nation, they are not able to dispose of the e-waste properly. So they send it to developing nations like India, and it's not the government of India accepts. This waste is purchased by the companies of India on the pretext of using it, but they hardly use it. They are responsible for recycling it, and that is the concern, that India is considered to be a dumping station of e-waste by developed world. So that's one concern. Second concern is what? E-waste consists of hazardous substances also. Improper disposal of e-waste can result in accidents. We have talked about Mayapuri accident yesterday in the class, that in 2011 Mayapuri accident took place. And Mayapuri accident took place how? Because a lab equipment was sold by a sold to a kabadi wala by the Delhi University, and the Delhi University was responsible for selling it to the kabadi wala. What happened because of this was that the kabadi wala was responsible for disposing it improperly, and in such disposal he used what? He used hammer to dispose it. So when this waste was hammered, which was a lab equipment, leakage of radioactive substance took place. And this radioactive substance which leaked from this waste was cobalt 60. Cobalt 60 was leaked. And when this leakage took place, then immediately there was a concern that how irresponsible is DU for selling a lab equipment to a kabadi wala. And why irresponsible is the word? Because there is a law governing it. In the year 2007, we can see a law was passed, and this law was called as Electrical and Electronic Waste Equipment Rules, according to which the disposal of this waste would be done by authorized agencies of the government. Authorized agencies of the government. So disposal would be done by them, and for which This should be approved by these authorized agencies, should be approved by the CPCB or SPCB. So this was the law. This was the law which was passed. So it said that the it was Delhi University was held for what? Delhi University was responsible for giving, selling lab equipment to Kabadiwala without, and we can see obeying these rules. So it was in violation of these rules that the Delhi University did it, and that's why Delhi University was blamed for this purpose. So that's another thing that you have to know. And then, as far as e-waste is concerned, e-waste consists of a number of hazardous substances. So let's see what hazardous substances are present in e-waste. Write down. E-waste. E-waste is the type of waste which includes waste is a type of waste which includes electrical or electronic circuit, electrical or electronic circuit, electrical or electronic circuit, as well as a power source. I write also electrical and electronic circuit, as well as a power source. Let me share the screen also to you. As well as a power source. Power source. Power source. As well as a power source. Clear? So that's the definition of e-waste. Now, e-waste is a concern in India. E-waste is a concern in India, as India is considered to be, a dumping station, as India is considered to be a dumping station of e-waste, dumping station of e-waste, by the developed nation, dumping station of e-waste by the developed nations, by the developed nation. Clear? So it's considered to be a dumping station of e-waste by the developed. And why? Because either the disposal mechanism of e-waste is a costly affair, or we can see it is energy intensive process. Even developed countries are not responsible for disposing of e-waste properly. Right on. Either the disposal mechanism of e-waste, either the disposal mechanism of e-waste, disposal mechanism of e-waste is a costly affair, is a costly affair, for example, hydrometallurgy, for example, hydrometallurgy, or is energy intensive process, or is energy intensive process, or is energy intensive process. For example, pyrometallurgy, pyrometallurgy, pyrometallurgy. And that's why we are saying that the disposal happens to be difficult, and that's why the developed country, they sell this waste to private agencies in India, and India is called as a dumping station of e-waste by developed nations as such. Dumping station of it. It's not that the government purchases this waste, it's called as the dumping station of e-waste by developed nation. Clear? First thing that you have to know. But the thing is what are the main attractions of e-waste? Now, the main attractions of e-waste include what? It includes gold. Right down. There are three main attractions of e-waste. There are three main attractions of e-waste. First, gold, which is present in capacitors. Gold, which is present in capacitors. Goes in capacitors, and that's why we are saying that pyrometallurgy would be used for extraction of gold. Gold which is present in the capacitors. Second, copper, which is present in wires. Copper which is present in wires. And third, plastic. And third, plastic, which is bulk part of it, which is bulk of it. So bulk of it is nothing but plastic. So the what is present in abundance in e-waste is nothing but plastic. Clear? So there are three main attractions of e-waste: gold, which is present in capacitors; copper, which is present in wires; and plastic, which is bulk part of it. Clear? So three main attractions. But then, suppose we consider that what is the component of plastic? As far as plastic is concerned, we can see that a bulk of it is nothing but plastic. Then you have cadmium also present in it, lead also present in it, mercury also, arsenic also, and then the others would be there. But as far as bulk of it is concerned, bulk of it is nothing but plastic. So this is your plastic in bulk. This is others. This is your cadmium. This is lead. Mercury is also part of it. And arsenic is also. But in bulk, what is present is plastic. We can say in bulk, what is present is plastic. So that's the depiction of the abundance of plastic present in e-waste. First thing. Now, the second thing that you have to know is that e-waste can be divided into three category of goods. One good is called as what? It is called as white good. Second good is called as what? Second good is called as gray good and brown good. And third good is called as what? It is called as brown good. So e-waste can be divided into three types of goods. Now, what does white good include? White good includes home appliances, mixture, juicer, etc. Brown good includes TVs and cameras. And gray good includes what? It includes communication devices. So you can see 70% of e-waste in India is nothing but gray goods. Right now, e-waste can be divided into three categories. E-waste can be divided into three categories. Three categories. First, white goods. White goods. It consists of home appliances. White good. It consists of home appliances. Brown goods. Brown goods. It includes TVs and cameras. Brown good. It includes TVs and cameras. And third, gray goods. It includes communication devices. It includes communication devices. And we can see about 70% of goods in India, e-waste in India is nothing but what? It is nothing but grey goods. Write down about 70% of e-waste in India. 70% of e-waste in India. E-waste in India is grey goods. About 70% of e-waste in India. E-waste in India is grey goods. Clear? So that's the concern. One concern is this. So some concerns I have talked about. Clear? But this is not about all the concerns. There are many other concerns related to e-waste. Some concerns I have discussed, but there are many other concerns related to e-waste. And let's talk about all these concerns one by one. See, when you talk about e-waste, not only India is considered as dumping station, not only these things are present. And the one concern is what? That disposal mechanism of e-waste. E-waste should be disposed safely, because improper disposal can result in Mayapuri accidents. Can result in accidents. You can give the example of Mayapuri accidents. Write down disposal mechanism of e-waste. Disposal mechanism of e-waste should be secured. Disposal mechanism of e-waste should be secured. Should be secured as improper disposal of e-waste. As improper disposal of e-waste. Let me just share the screen again for some words and some text. As improper disposal of e-waste can result in accidents. Can result in accidents. Result in accidents. And the best accident that we can recall is Mayapuri accident. Mayapuri accident, 2011, Delhi. And what happened? A lab equipment was sold to a Kawadiwala by the Delhi University, because of which this accident took place. So that's your Mayapuri accident. Clear? Mayapuri accident. Now, next thing that you have to know here is that as far as e-waste is concerned, in India, e-waste is also a big concern. Why? Because more than 95% of e-waste in India is disposed by the unorganized sector, as the authorized units in India is very low. Right down. More than 95% of e-waste, more than 95% of e-waste, 95% of e-waste is disposed by the unorganized sector, is disposed by the unorganized sector, as the approved units for this disposal, as the approved units for such disposal, approved units for such disposal is very less in India. Approved units for such disposal is very less in India. is very less in India. Clear? Very less in India. So that's another concern for India. But then one concern is also that as far as e-waste is concerned, e-waste consists of a number of hazardous substances. And let's look at the hazardous substances and what they would be responsible for, how they would be responsible for affecting us. Right down, e-waste also consists of hazardous substances. E-waste also consists of hazardous substances. E-waste also consists of hazardous substances. Hazardous substances which have adverse impact on human health, which have adverse impact on human health. And let's consider these hazardous substances as such. Now, the first hazardous substance is what it is called as americium. Americium. Now, americium is a hazardous substance which is present in a device, and this device is called as smoke alarm. Smoke alarm. And americium which is present in it is reported to be what? It is reported to be carcinogenic nature. Carcinogenic means it would be responsible for causing cancer. Reported to be carcinogenic in nature. That's about americium. Clear? Now, the second hazardous substance is what? It is mercury. You can write mercury. Mercury. And mercury is present where? It is present in the computer monitors. So it is present in computer monitors. Computer monitors. And it is responsible for computer monitor, and it is responsible for monitors, and it is responsible for dementia. Dementia means loss of memory. So it is responsible for dementia, which is loss of memory. Clear? So that's mercury. The third is called as what? The third is cadmium. Let's yes. Let's take a first of all sulfur, not cadmium, sulfur. Now, sulfur is present where? It is present in your lead acid battery. Lead acid battery. And this sulfur is responsible for what? It is responsible for liver and kidney damage. Liver and kidney damage. The next thing which is present in e-waste is cadmium. Cadmium. Cadmium is present in the rechargeable batteries that we use. A rechargeable battery that we use, and this is responsible for lung and kidney damage. So damage to lung and kidney takes place. Clear? Then there is a substance which is called as lead solders. Soldering, you understand. Fifth one is lead solder. Now, soldering takes place in circuits. So, lead solder would be present in circuits. And this, the adverse impact of lead solders is what? It is responsible for lack of cognitive behavior. Lack of cognitive behavior. It means that generally it is seen in children, and it is the symptom of a disease which is called as what? It is referred to as, it is symptom of a disease which is referred to as uh, very famous disease among children, that is, and it is characterized by the disease is called as autism, and it is characterized by lack of cognitive behavior. So the children cannot comprehend things properly. So that's called as the lack of cognitive behavior. Now, next we can see that some others also. 5 we have covered up. Then there is also let's cover up some more. One is called as BFR. BFR you have studied. BFR you studied when you studied ozone layer. That is called as brominated fire retardants. Now this is present where? This is present in the plastic component of e-waste. Plastic part of e-waste. Plastic part of e-waste. And this is responsible for what? This is responsible for hormonal imbalance, because you know that it is a endocrine disruptor. The next which is present is called as what? It is called as hexavalent chromium. See, you would have seen that there are steel plates in your laptop, but these steel plates do not bend. They are very hard. So we can see that the hardness of the plate is due to a substance which is called as hexavalent chromium. So this hexavalent chromium is a hardener for steel plates. Hardener for steel plates. This is considered to be a hardener for steel plates. Clear? And this is responsible for DNA damage. This is responsible for DNA damage. So that's another concern. Hexavalent chromium, which is used for hardener for steel plates, is responsible for DNA damage. Clear? So all these are the hazardous substances present in e-waste that you have to remember. Clear? Hazardous substances which are present in e-waste and that you have to remember. Fine. So all these other concerns, hazardous substances are present. Clear. So these are the concerns that you have to remember. All these other concerns. Now, see, a type of e-waste is also what is called as solar waste. Clear. And the concern is because India has targets for developing renewable energy, and we are targeting that. So the solar waste in India would be enhancing. One target is that by the year 2030, 2 lakh tons of solar waste would be generated. But the second statistics suggest also that by 250, 1.8 million tons of solar waste would be generated in India. And this is a concern. And why this is a concern? Because as far as solar waste is concerned, in solar waste, chromium, cadmium, sulfur hexafluoride are a matter of concern. But solar waste also consists of what? It also consists of the glasses, it also consists of aluminum, which is not a matter of concern for us. But these substances, cadmium, chromium, etc., are a matter of concern for us. Now, a part of solar waste, sorry, a part of e-waste, a part of e-waste is solar waste. Let me see if suppose you have asked you any questions. A part of e-waste is solar waste, is solar waste. And a part of e-waste is solar waste, and by the year 2050, by the year 2050, and by the year 2050, 1.8, and by the year 2050, 1.8 million tons of solar waste, 1.8 million tons of solar waste would be generated by India. 1.8 million tons of solar waste would be generated by India. 1.8 million tons of solar waste would be generated by India. Generated by India. Clear? So that's the statistics. But then do remember that as far as solar waste is concerned, in solar waste, glass or aluminum is not hazardous for us. Right now, in solar waste, in solar waste, in solar waste, glass, in solar waste, glass, and aluminum, because its solar panel consists of the aluminum plates, the glasses also, and the aluminum beads also. In solar waste, glass and aluminum is not dangerous for us, is not hazardous for us, is not hazardous for us. But chromium, cadmium, and sulfur hexafluoride, let me write down because there may be spelling mistakes also. But chromium, cadmium, and hexafluoride, cadmium and sulfur hexafluoride, not hexafluoride. Sulfur hexafluoride are detrimental for us, dangerous for us, are detrimental for us. detrimental for us. Clear? So that's these things are not good for us. They are detrimental for us. But what steps have been taken for e-waste? Now, one step which was taken for e-waste was in the year uh, 2007. And in this year, we can see that electrical and electronic waste equipment rules were passed, according to which these waste should be disposed by authorized agencies of the government, and they should be approved by either SPCB, that is State Pollution Control Board, or CPCB. So those are the measures which have been taken. So one by one, let's discuss the measures. What are the measures which have been taken? Right on measures. First, in the year 2007, electrical and electronic equipment waste rules, electrical and electronic equipment waste rules were passed. Equipment waste rules were passed. Equipment waste rules were passed, according to which disposal of e-waste, should be conducted by authorized agencies of the government. Should be conducted by authorized agencies of the government. Authorized agencies of the government, approved by SPCB or CPCB. SPCB, that's State Pollution Control Board, or CPCB, that's your Central Pollution Control Board. Central Pollution Control Board. But just remember that more than 95% of e-waste in India is disposed by the unorganized sector. But on the other hand, more than 95% of e-waste in India. But on the other hand, more than 95% of e-waste in India. 95% of e-waste in India is disposed by the unorganized sector. Is disposed by the unorganized sector. Now, this was the first step taken. In the year 2011, we can see the government of India asked private companies to establish collection centers for e-waste. And why collection centers for e-waste should be established? Collection centers of e-waste should be established so that this waste can be segregated from the general waste. Right now, in the year 2011, Government of India asked private companies. Government of India asked to establish collection centers for e-waste. To establish collection centers for e-waste. Collection centers for e-waste. so that this waste can be segregated from the general waste. So this was done. Collection centers for e-waste. Clear centers for e-waste. So that this can be separated from the general waste and can be disposed properly. So that was in the see what happens in India. If India is regarded as a dumping station of e-waste by the developed nation, then in India, what happens? E-waste from other parts of India come to Delhi and they are disposed in unorganized units of Delhi. So that's a big problem. It should be in uh, big industry, and it would should not be in like this. So we can see that what was done in the year 2013, the government of Delhi decided to impose a very high tax on transportation of e-waste from the other parts of India to the territory of Delhi so that it can act as a disincentive. But since this is state specific measure, we won't be responsible for including this in our notes. Clear? But we can see in the year 2011, the government of India asked private companies to establish collection centers for e-waste so that it can be segregated from the general waste. So that is one initiative. And in the year 2016, we can see, e-waste management rules were passed. Around in the year 2016, e-waste management rules were passed. E-waste management rules were passed. And what is under e-waste management rules? What you have to learn about under e-waste management rules? We can see under e-waste management rules, the collection, disposal, and e-waste, and also collection, recycling of e-waste should be done by the private companies themselves under EPR, that is extended producer responsibility. Right on under e-waste management rules, under that's the second step. Third step, you can see e-waste management rules. (2016) e-waste management rules 2016. Collection, recycling, and disposal of e-waste. Collection, recycling, and disposal of e-waste should come under EPR. EPR stands for what? EPR stands for extended producer responsibility, because it's the producer which is responsible for benefiting from it. Extended producer responsibilities. Extended producer responsibility. So that's one thing which was said in the e-waste management rules, that collection, disposal, or recycling of e-waste should be coming under EPR, extended producer responsibility. And the second thing which was mentioned, in that was that CPCB is the only agency which would be responsible for ordering the disposal of e-waste. Around CPCB, the power has been taken from SPCB. CPCB is the only agency. CPCB is the only agency. That's your Central Pollution Control Board, for approving the disposal of e-waste. Is the only agency for approving the disposal of e-waste. Clear So this was included in biomedical waste, sorry, e-waste management rules 2016. And the last in this category, that one initiative was taken in January 2023. And that initiative is what? That initiative is that the developer has to give information about the constituents or ingredients of the commodity. Whenever asked by the, suppose CPCB is responsible for asking it, so it has to deliver back. Write down, write down. According to a recent order, according to a recent order, according to a recent order, just write down the date, January 2023, January 2023. The developer, the developer, the developer can ask information about the ingredients of, can ask information about the components or ingredients of this waste. Components or ingredients of this waste. Components or ingredients of this waste. So that's your recent, that was passed in January 2023. And all these things you have to know about the electronic waste. Let's come back to the screen again, face to face. Clear? So let's come back and discuss some other forms of pollution. Now see, one form of pollution is called as what? It is called as noise pollution, that we have to cover up. Then another form of pollution is called as space degradation, that we have to cover up. Biomedical waste needs to be covered up. Microwave pollution needs to be covered up. So all these needs to be covered up today. Clear? First of all, just 1 second. Just take water and come back. I'm not at all well today, but I did not want to stop the class. Clear? So I did not want to stop the class. That's why I continued from. But I won't allow you to face any inconvenience. I'll use the board for this purpose. All these would be used. Clear? So let's cover up the remaining portions. Now, one wish that you have to know is called as what it is referred to as Minamata Convention deals with mercury. Sir, please say something about this convention. See, Minamata Convention deals about mercury and it is to disallow the bioaccumulation of mercury. The purpose is to disallow the bioaccumulation and also to say that mercury should not be present in our natural ecosystem. But that is not the case. Mercury is present in the atmosphere today. And this type of mercury, which is present in the atmosphere today due to anthropogenic activities of the past, due to human activities of the past, is called as what it is called as legacy mercury. And the problem is what that this mercury has been absorbed in the soil, and also not only absorbed in the soil, it is also absorbed in the permafrost region. So suppose we are saying that melting of permafrost region takes place due to global warming, mercury contamination of rivers and oceans would be enhancing. Sir, EPR concept is not clear. Please discuss this. Yes. See, EPR means suppose I'm the producer, I'm the developer. Now, EPR means extended producer responsibility. Now, I have manufactured this pen. Clear. Now, due to this manufacturing, or suppose the industrial unit that I have, there would be adverse impact on the environment. Clear. So it's my responsibility because I am earning profit from that commodity. So it's my responsibility towards that area, towards the product. Because if suppose this product is responsible for harmful impact, I should be responsible for taking all these safeguards that this does not happen. Clear? And I have discussed collection of what? I have discussed EPR in connection with what? In connection with collection, recycling, and also disposal of e-waste. Why? Because the developer should be responsible. They are earning profit from these commodities. If suppose you purchase mobile, who is earning profit? They are earning profit from these commodities. Clear? So they should be responsible for what? They should be responsible for also disposal of it. Clear? So that's called as EPR. Either you can recycle it or you can dispose it. So since you are earning profit on that commodities, it's your responsibility that you would be responsible for recycling, disposing, or collecting it and removing it. Is that clear? Does this EPR and PPF, polluter pays principle, concept similar? No, there are two different concepts. Polluter pays principle means what? Polluter pays principle means that those who were, now that is in the context of what? That is in the context of developed nation. This is in the context of private companies. Clear? This is in the context of private companies. Now let's deal with another type of pollution here, and a small only, and that is called as what? That is called as noise pollution. Let's cover up noise pollution. First of all, in noise pollution, what you have to know is you have to know the different levels. A small 5 minutes, and also what initiatives have been taken in India for this purpose. So let's come to the screen and discuss the different levels of noise pollution. Write down noise pollution. Noise pollution. Let's see the different levels of noise pollution. Now, suppose the noise is 10 decibel. The noise is what? The noise is 10 decibel. Decibel. dB is for decibel. Suppose the noise is 10 decibel. We can see that this kind of noise would be called as what? This kind of noise would be called as just audible. Now, if it is 20 decibel, we will say that this is whisper. 20 decibel, then it is whisper. If suppose it is from 35 to 60 decibel, then it is normal conversation in India. Normal conversation in India. 35 to 60 decibel. Clear? And but just remember one fact. That above 45 decibel is noise pollution according to WHO. So what is normal conversation in India is nothing but noise pollution according to WHO. Noise pollution according to WHO. Clear? And as far as more than 80 decibel is concerned, then we say this is noise pollution in India. Noise pollution in India. If it is 120 decibel, if it is 120 decibel, then we can see that this would be damaging the eardrums. And if suppose it is 180 decibel, 180 decibel, then there would be death because the heartbeat is going to stop. So these are the noise levels. Just register it. I wait for a few seconds. Just register that. And see, let's also talk about what initiatives has been taken in India. One initiative which has been taken in India is establishment of what is called as silent zone areas. Silent zone areas means not these areas where the noise level will be checked. So silent zone areas have been established near hospitals, near educational institutions to a range of about 100 meters, not 100 kilometers, 100 meters. So that is called as silent zone area. Right on steps. Silent zone areas. Silent zone areas have been established. Near educational institutions. Silent zone areas have been established near educational institutions. And hospitals. Within a range of not 100 kilometers, 100 meters, within a range of 100 meters. So that's the first step. Silent zone areas have been established near educational institutions and hospitals within a range of 100 meters, not 100 kilometers, 100 meters. So that's one step. Second, we are responsible for establishing also what is called as green mufflers. So green mufflers would be established on both sides of the roads. So they are called as green mufflers. So down. Green mufflers would be established. Green mufflers have been established. Have been established on both sides of the road. Green mufflers have been established on both sides of the roads. Both sides of the roads. Green mufflers have been established on both sides of the roads. Both sides of the roads. Clear. Both sides of the roads. And we can see this is not only responsible for checking noise pollution. Why? Because the noise which is taking place from vehicles would be disallowed to reach the residential areas because of green mufflers. So that's how it would be working. But it's also responsible for reducing air pollution because it would be performing photosynthesis and responsible for reducing air pollution. And trees are always responsible for reducing air pollution. Right? It not only is responsible for reducing, it is not only responsible for reducing air pollution, but also it's not only responsible for reducing air pollution, but also noise pollution, but also noise pollution, also noise pollution. Noise pollution. Clear. Now that's about green mufflers. The third step which can be taken, see, a noise pollution for us is nothing, but it's mainly for the industrial workers. Clear. So because the noise comes out from the machines. So government of India, in India, we are responsible for providing the earmuffs to industrial workers. Now, in India, we also provide earmuffs earmuffs to industrial workers. To industrial workers. Clear. So all these steps have been taken, and do remember that as far as noise pollution is concerned, we can develop also sound mufflers. Sound mufflers. Now, a reference to sound mufflers can be made. As far as noise pollution is concerned, we can also develop sound mufflers. So, reference to sound mufflers can be made. Now, Russia, it used a submarine to reach the Swedish coast. And this submarine had a rubber pad beneath it, which acted as a sound muffler. So, usually the submarines are detected by their noise that they are responsible for emitting. But because of these sound mufflers, the noises were not captured by the sonar. In future, we can use a material which is called as metamaterial. And this metamaterial would be used as sound mufflers because it has the ability to alter the seismic waves. It has the ability to alter not only the seismic waves but also the sound waves. So this kind of metamaterial can be used. Metamaterial is a material which has been developed in US, and this is made up of what? This is made up of foam, not only foam but also the photonic crystal, the light crystals, and wire. So three things has been used for developing metamaterial. This material is based on what? This material is based on zero reflection and zero reflection. Suppose this is the metamaterial. What happens? We can see this box. Why? Because this is Visible to us. Why? Because when light comes, it strikes the surface and return back to our eyes, so we can visualize it. Had it been that the light would have passed through it also, we would have seen that. Clear? But if suppose light comes, neither gets reflected nor gets refracted, but just light comes like this is coming, bending and passing over it, this material won't be visible. Clear? Such a material would be called as what? It would be called as metamaterial. Such type of material would be called as metamaterial, which is based on zero reflection and zero refraction. So it can be invisible also. Zero reflection and zero refraction. So it can be invisible also. So this kind of material is referred to as metamaterial. Clear? Metamaterial. That you have to know. So if a question is asked in examination related to invisibility, don't be astonished, because invisibility can be attained with the help of metamaterial. But metamaterial has a characteristic that it can change the sound waves and also the seismic waves. So it can be used to develop a sound muffler, and it can be used for earthquake resistant building also. Why? Because it has the ability to alter the earthquakes. Now, sound mufflers can also be developed for this purpose. We are talking about not green mufflers here. Sound mufflers can also be developed. Sound mufflers can also be developed with the help of sound mufflers can be also developed with the help of metamaterial. Metamaterial. This material has the ability. This material has the ability to alter. This material has the ability to alter. Not only seismic waves. So it can be used in future in earthquake resistant buildings. Not only seismic waves, but also sound waves. And as such, we can see that this can be used for what? This can be used for making sound mufflers. Write down. In future, sound mufflers can be developed. In future, sound mufflers can be developed. With the help of metamaterial. With the help of metamaterial. Metamaterial. This material is based on zero reflection and zero refraction. This material is based on zero reflection and zero refraction. Reflection and zero refraction. Clear? So one can say this is invisible also. Now, metamaterial, how it is developed and how it functions. When light rays falls on metamaterial, it does not get reflected or refracted, but it is reverted back. Right on. When light rays falls on metamaterial, it neither gets reflected nor refracted. But bends and passes over it. Bends and passes over it. So this is called as metamaterial. Clear? Metamaterial consists of what? It consists of foam, photonic crystal, and wire. Now, metamaterial consists of what are the composition of it? Foam, photonic crystals, photonic metamaterial consists of foam, photonic crystals, and also wire. So it has been developed in US, and the transfer of technology cannot take place to any other nations. This material is invisible and it can be used as sound mufflers. Clear? It can be used as sound mufflers. So that's about the noise pollution that you have to know. But see, there is a type of waste which is always in the news. Clear? And this type of waste is called as what it is referred to as. Just return back to the screen again. See, let's discuss first of all, and then we'll write. Every time, don't have to go back to the screen. One. There is a type of waste that you have to know. And this waste is called as what? This waste is called as biomedical waste. They haven't asked you a single question on biomedical waste. Let's see your queries first of all. Sir, could you explain again EPR in e-waste management rules 2016? Yes. See, EPR in e-waste management rules 2016 means what? That the responsibility of collecting this waste, the responsibility of recycling this waste, the responsibility of disposal of this waste falls now on whom? Falls now on nothing but the producer. Because it is the producer which is responsible for producing that product through which this waste develops. Clear? So it is the producer which is responsible for earning profit on it. So if this waste is going to damage the environment, the responsibility is on the producer to collect in and dispose it properly. Now, sir, as far as I can recall about the disposal of solar waste, it would be responsibility of the company for the disposal of solar waste. To what extent it is true? See, solar waste is a form of renewable energy. And if solar waste is responsible for generating into electronic waste, then one thing is that one benefit it gave to us was to reduce our dependency on the grid energy. But the second thing is what? Second thing is what? That this waste would be generated from solar panels and the system which is used there. And this would be hazardous for us. Hazardous for us. Clear? So that's why we are talking about that giving responsibility to the solar companies to collect these waste and dispose it properly. In that context, I have told you also that what kind of waste is dangerous and what kind of waste is not dangerous. For example, cadmium, chromium, all these are dangerous for us. Sulfur hexafluoride, which comes out of the batteries, all these are harmful for us. But then the cadmium, the chromium, the sulfur hexafluoride, which has been used, which is present in solar waste, is hazardous for us. Sulfur hexafluoride is itself a greenhouse gas recognized in the Kyoto Protocol, SF6, you can see. Next question. There are many hospitals and schools situated beside the road. Is it legal? See, hospitals and schools should be situated, but the legal illegal depends upon what about the noise level that we have discussed. That within a range of 100 meters near the hospitals, the noise level should be less. It's not that they cannot be situated. Unbearable sound is formed from thunderstorm as it is natural phenomena and can be avoided. Then what we can do and avoid the adverse impact of high sound created by thunderstorm. See, the sound which is created by thunderstorm, more damaging is the sound which is created through cloud bursting. Clear? But as far as thunderstorm is concerned, the impact of the thunderstorm can be checked, but you cannot check the thunderstorm. They would generate because they are natural phenomena. Clear? The impact of cloud bursting can be checked, but you cannot prevent cloud bursting to happen because Himalayas are prone to cloud bursting, and naturally they are prone to cloud bursting. Sir, is not foam caused by global warming then is not more loss than profit of. Now it is, the question is not foam caused of global warming, then it is not more loss than profit of use in metamaterial. See, foam we are discussing here, that foam is mixed, not only foam is mixed with photonic crystal, that is the light crystal. It is mixed with what? It is mixed with photonic crystals also. And then we can see wire is also used for this purpose, developing metamaterial. So it is in the incipient stage only. That's why I said that this would be used in future. You don't have to talk about foam over here. Foam can be generated from many mechanisms as such, not one mechanism through which foam would be generated. Just let me get one face wash and then come to you. Just 1 second. As far as metamaterial is concerned, the making of metamaterial is in the incipient stage. But since news came out of metamaterial, that's why we are using metamaterial in sound pollution or noise pollution. Clear? That's we are responsible for using it. Otherwise, as far as metamaterial is concerned, don't have to write much about metamaterial, but in future, we can use this for sound mufflers. In future, we can use this for also other purpose. That's about metamaterial. But let's discuss another type of waste. They haven't asked you a question on that. And that is called as what is called as biomedical waste. Now, when we talk about bio, and don't have to write in examination that it consists of soiled syringes, it consists one or two things, not to make a list of all these things, human body parts and kidneys, etc. No, biomedical waste are those waste which are biological in origin. So they originate biologically, and they are responsible for what? They are responsible for causing to us infectious diseases. That kind of waste would be called as biomedical waste, which is biological in origin and is responsible for causing infectious diseases. Clear? Infectious diseases. Now see, when we are talking about biomedical waste, we can see if you take hospital waste, biomedical waste also consists of hazardous substances. But if we talk about hospital waste, 15 to 18% of hospital waste is what? It is hazardous in nature. Out of which we can see, if suppose we consider the hazardous component only, out of which we can see that roughly about uh, 10 to 25% would be infectious in nature. Infectious in nature. Now, the first law related to biomedical waste was passed in US in 1988. Was passed, which was called as Medical Waste Tracking Act. 10 years after in India, we were responsible for passing a law related to biomedical waste. And this law was called as Biomedical Waste Disposal Act. This was referred to as what? It was referred to as the biomedical waste. Biomedical waste, just 1 second. It was referred to as Biomedical Waste Disposal Act. Clear? So this was passed in India in 1998. It was passed in India in 1998. Just 1 second. Let me adjust it. In 1998. And after this, we can see, 1 second, let me adjust it and then come to you. After this, we can see that that was the Biomedical Waste Disposal Act. But on November 28, 2013, there was a judgment given by NGT. NGT means National Green Tribunal. Now, that tribunal gave a judgment, and the judgment which was given was that we can dispose of biomedical waste only after EIA has been conducted for this purpose. Environment impact assessment has been conducted for this purpose. Then only the disposal of biomedical waste would be done. Otherwise, it cannot be done. Clear? So that was said in the year 2013 by the NGT. Then we can see that after this, in the year 2018, biomedical waste management amendment rules were passed. And under biomedical waste management amendment rules, we can see that first thing was that the chlorinated plastic bags, which you have earlier also studied in plastic pollution, that is chlorinated plastic bags and gloves were banned in hospitals. Only exception was blood bank. Clear? Because that's emergency kind of situation. But chlorinated plastic bags and gloves were banned. And why these were banned? Because when you incinerate it, when you burn it in the form of, it's taken in the form of biomedical waste and incinerated, then emission of toxic gases takes place like dioxin and furans. And you know very well, we have discussed earlier that dioxins and furans are carcinogenic in nature. They would be responsible for causing cancer. So they are carcinogenic in nature. So that's called as dioxins and furans. Second part of it is what? The ambit of biomedical waste has been enlarged under these rules. And how? The ambit has been enlarged. Now we can see that waste from not only hospitals and clinics, but waste from healthcare facilities, waste from blood donation camp, waste from not only healthcare facilities and blood donation camp, but also waste from other areas. For example, the vaccination centers, all these will be considered as biomedical waste. So the ambit has been enlarged. In order to separate biomedical waste, the barcodes would be given so that it can be separated from the general waste as such. So the barcodes would be given for this purpose in order to separate the biomedical waste from other waste. And it calls for immediate disposal of biomedical waste, and that is by the process of what? By the process of incineration. All these things were included in biomedical waste. But see, just one second. But see, as far as biomedical waste is concerned, you have to see also that disposal mechanism. There are two types of disposal mechanism in biomedical waste. One more thing that I missed, that in the year 2020, the biomedical waste disposal guidelines were given by CPCB, that is Central Pollution Control Board. So this was given by CPCB, Central Pollution Control Board, and this was given for amidst the COVID pandemic. And the guideline was to collect the biomedical waste from quarantine centers. The words that now we have forgotten: quarantine centers and isolation wards, in double layered plastic bags, which should be yellow colored, so that we know that this is coming directly from the quarantine centers or it is coming from the isolation wards. And also calls for disposal of this kind of waste immediately. Disposal of this kind of waste should be done immediately. Clear? So that should be done. Clear? That should be done. And this was included in biomedical waste guidelines, which were given by CPCB. Clear? CPCB. But there's another thing also which needs to be covered up in biomedical waste. One thing which should be covered up in biomedical waste is that as far as biomedical waste, there are two mechanisms of disposal of biomedical waste. One is called as in situ, and second is called as what? It's called as ex situ disposal. In situ disposal, and second is called as ex situ disposal of biomedical waste. And in situ disposal means that it would be disposed. In situ disposal means that it should be disposed at the place of its origin only. Clear? Suppose big hospitals are responsible for in situ disposal of biomedical waste. But as far as ex situ disposal is concerned, but in situ disposal would be always a costly affair. Ex situ disposal is what is frequently used. And ex situ disposal would be done how? Ex situ disposal would be done when the waste is transported from that area and then disposed. But before transportation, what you have to use is, before transportation of biomedical waste, you have to use a device which is called as autoclave. Autoclave means that steam would be generated and passed under pressure of this over this waste, and when it is passed under pressure over this waste, then the microbiological load, the germ load of this waste would be reduced. So that's called as what? That's called as autoclave. And suppose that waste is a liquid, then what to do for that purpose? So we would be using what? We would be using sodium hydroxide for this purpose, and that would be responsible for making the liquid germ free. Then the main method of its disposal is incineration only. This much you have to learn in biomedical waste. Let's write down it also. Let's write down. Write down biomedical waste. Biomedical waste. Biomedical waste. This type of waste, this type of waste this type of waste is biological in origin. This type of waste is biological in origin. Biological in origin. And responsible for spread of infectious diseases, and responsible for spread of infectious diseases. This type of waste is biological in origin and responsible for spread of infectious diseases. Infectious diseases. Clear? That's the first part. And there are many things which can be included. For example, soiled bandages can be included in that. For example, human body parts. But you don't have to make a list of these. Expired drugs also. Expired drugs also. The list includes many. So don't have to make a list. But these are some of the waste which are called as biomedical waste. Soiled bandages means used bandages. Human body parts, for example, kidney has been replaced, or human blood also. And expired drugs. So all these things. Clear? Next, write down that among the hospital waste, suppose we consider the hospital waste, among the hospital waste, (15 to 18%) is hazardous in nature. 18% is hazardous in nature, and among it 10 to 25%, and among it 10 to 25% infectious in nature, and among it 10 to 25% infectious in nature. Infectious in nature. Infectious in nature. Clear? So that's the about biomedical waste, hospital waste. Now we can see the first law related to it was passed in US. The first law related to biomedical waste. The first law related to biomedical waste was passed in US. In 1988. Was passed in US in 1988. Which is referred to as, which is called as medical waste, which is called as medical waste. Tracking Act. Medical Waste Tracking Act. Medical Waste Tracking Act. Tracking Act. In the year 1998, see in India also we followed. In the year 1998, Biomedical Waste Disposal Act. Biomedical Waste Disposal Act was passed in India. Biomedical Waste Disposal Act was passed in India. Passed in India. Clear? Then we can see on November 28, 2013, the NGT gave a judgment right on November 28, 2013. NGT stated, that is National Green Tribunal. NGT stated that without environmental clearance, environmental clearance is what? Just a type of EIA. Without environmental clearance, disposal of biomedical waste cannot take place. Disposal of biomedical waste without environmental clearance. Disposal of biomedical waste cannot take place. Disposal of biomedical waste cannot take place. So this was stated by whom? It was stated by the NGT, that is your National Green Tribunal. Fine. So National Green Tribunal stated this. NGT was responsible for stating this. Fine. So it required environment. There was a case in which this judgment was given by the NGT. Fine. Now, after this, we can see that in the year 2018, biomedical waste, I'm writing BMW in short, does not mean cars. Biomedical waste management amendment rules were passed. Right? In the year 2018, biomedical waste management amendment rules were passed. Biomedical waste management amendment rules were passed. According to which chlorinated plastic bags, and gloves have been banned. Chlorinated plastic bags and gloves have been banned. The only have been banned in hospitals, etc. So we can see only exception was given for blood bank. Otherwise, it has been banned. And why so? Because incineration of this was responsible for emission of dioxins and furans. So when you burn this as a type of biomedical waste, it was responsible for emission of dioxin and furan. Then dioxin and furan you have studied in plastic pollution is carcinogenic in nature. Right? As incineration of this waste, was responsible for emission of as incineration of this waste was responsible for emission of dioxins and furans. And you know about dioxins and furans. We have discussed earlier, which are reported to be carcinogenic in nature. Which are reported to be carcinogenic in nature. Reported to be carcinogenic in nature. Clear? Reported to be carcinogenic in nature. That they are responsible for causing cancer. Now, that's one thing which has been mentioned in the Biomedical Waste Management Amendment Rules of 2018. But another thing which has been mentioned is that the ambit of biomedical waste has been enlarged. The ambit of biomedical waste has been enlarged. Ambit of biomedical waste has been enlarged. Ambit means the extent, because it's not only that from hospital or the clinics the waste which would be coming would be called as biomedical waste, but also the waste from vaccination centers, blood donation camps would be also referred to as biomedical waste. Right out. The waste from vaccination centers, healthcare facilities, blood donation camps, would also be referred to as biomedical waste. Clear? And we can see that for the segregation of this waste, because all these waste would be mingled together, mixed together. So for the segregation of this waste, barcodes should also be used. For the segregation of this waste, barcodes would be used. For segregation of this waste, barcodes would be used. Clear? And calls for immediate disposal of biomedical waste. It also calls for immediate disposal of. Biomedical waste. And we can see amidst the COVID pandemic, CPCB guideline for biomedical waste were given. Right on. Amidst the COVID pandemic, amidst the COVID pandemic, CPCB, that is Central Pollution Control Board, CPCB guidelines for biomedical waste were given. CPCB guidelines for biomedical waste were given. And what are the guidelines? The guidelines included collection of this waste from quarantine centers and isolation ward in double layered yellow colored bag and called for immediate disposal. Right on. The guideline included collection of this waste, biomedical waste, from isolation wards. This was given in the year 2020. From isolation wards and and quarantine centers, from isolation wards and quarantine centers. Quarantine centers in double layered, so not a single layered, in double layered yellow color bag, double layer yellow colored bag, yellow colored bag, and called for what? It called for immediate disposal of this waste. No, it also called for, it also called for immediate disposal of this waste. It also called for immediate disposal of this waste. Immediate disposal of this waste. Disposal of this waste. Clear? So it was responsible for calling for immediate disposal of this waste. The next thing that you have to know here is that what are the mechanism of disposal. So there are two methods of its disposal, in situ and ex situ. There are two methods of its disposal. There are two methods of its disposal. After this, we will take the break. Two methods of its disposal: in situ and ex situ. In situ and ex situ. Now, in situ disposal would be taking place where? In situ disposal would be taking place where the waste is generated. It is a costly affair. Right now, in situ disposal is a costly affair. In situ disposal is a costly affair. Costly affair. Where ex situ is frequently used. Whereas ex situ is frequently used. But look, before transportation of this kind of waste, we would be reducing the microbiological load by using what? Microbiological load by using a device which is called as autoclave. Right on. But before transportation of this waste, in situ means that it would be disposed at the point of generation. But before disposal of this waste, a device called autoclave, a device called autoclave should be used. Autoclave should be used. And what is autoclave? Autoclave is a device which passes steam under pressure over this kind of waste. It is a device which passes. It is a device which passes steam under pressure. It is a device which passes steam under pressure. Steam would be generated and pressurized. Steam under pressure over this waste, so that the germ load gets reduced. So that the germ load, so that the germ load gets reduced. In other words, you can say it is for making the germ load gets reduced. Now, in other words, we can see it is for the purpose of making it sterilized. Germ load can be reduced. Clear? Fine. So all these are the necessary things that you have to. Now, if the waste is a liquid, then we can use sodium hydroxide. If the waste is a liquid, for bleaching purpose, sodium hydroxide is used. Bleaching purpose, sodium hydroxide is used. So all these are the methods of the disposal of biomedical waste and also the necessary steps. Let's see, return back to the screen and see the queries which have been. Let's see the queries. Some queries also. No more queries have been asked. All is clear. Doubts are also clear. So we'll halt it for the break right now. Clear. So let's halt it for the break right now. So if we come start new topic, it won't be complete midway, it would be left. So I have to introduce only that topic. So let's so at 2 o'clock we'll resume. And first of all, we'll complete this chapter because only one or two topics are left, so that can be completed. And then we will start with biotechnology. And after that, disaster management, because disaster management is also part of your syllabus.